Hello, fifth graders. I am back here today with lesson 13.3, which is about writing expressions to go with problems. So we're kind of turning it around what we've been doing the last couple days. The last couple days you've gotten expressions with parentheses and brackets and braces, and you've used the order of operations, that PEMDAS trick, to make sure that you're doing them in order and solving them correctly. Today, you're going to be given problems and situations and asked to create an expression that matches them. So we have to use PEMDAS in a different way. We have to think about, when do I need to use parentheses and possibly brackets and even braces to make sure that people reading and trying to solve my expression will do it in the right order and come up with the correct answer that I need them to come up with. So let's start with a couple of the guided problems on page 749. If you're following along, either you've tried them on your own already or you felt you needed to see the video to understand it a little better, then we'll go through them together. If you've already tried them on your own, then you're checking to make sure that you did them accurately. So in the guided practice section, we're going to start with number 2. Okay. Here's the expression you were given: 9 times 7 plus 44 in parentheses. And you were asked to think about 2 different properties you could write. So a little think back to, what are some of the other ways we know how to manipulate expressions before we start creating our own. So I'm seeing that in this expression, first I'm adding these 2 things together, and then I am multiplying by 9. And I know I'm adding first because of the parentheses. So what are 2 other ways I can do that? Well, I'm going to start with the easiest. The easiest property that we all know how to use is the commutative property, right? It's just switching it around. So if I use the commutative property here, that means I can switch around those 2 things that I'm adding because I know changing the order won't make a difference. So with the commutative property, I could simply change this to be 9 times 44 plus 7. I'm still adding those 2 things first. I'm still coming up with the same answer, 51, and doing times 9, so it won't matter. Now, if I want to use another property, associative doesn't work here because I'm not adding or multiplying 3 or more things. The other thing I can use when I'm adding and multiplying is distributive property. So let's take a look at what the distributive property would look like. Distributive property means that if I've got these 2 things that I'm adding and then multiplying them, another way I could do it is I could multiply 9 times each of them and then add the totals together. So I'm distributing the 9. I'm sharing it and everything else that I've got in the parentheses. So distributive property would look like 9 times 7 plus 9 times 44. Okay? And that would end up being the same as this. Okay, now let's look at some of the types of problems we're working with today. Numbers 3 through 6 give you a situation where you have more than one step and you're being asked to write an equation that matches that and gets you the right answer. So if I look at number 3 tells me to do 2 different things. Add 8 plus 7. Then there's a clue. That means this has to come second. So this is step number 1. And then step number 2 is to multiply by 2. This is where PEMDAS, my order of operations, comes in handy. I need this because if I just wrote 8 plus 7 times 2, just like the problem said, let's think about somebody looking at that expression. Using the order of operations, what would they have to do? If there's no parentheses, the first thing they would have to do is 7 times 2. And then add the 8. And that's not what this problem is asking me to do. This problem is asking me to add first and then multiply. That doesn't match the order of operations. The only way to tell people that they have to add first is by using those parentheses. That's how I make it the first step. So the correct expression for this would be 8 plus 7 in parentheses, then times 2 outside the parentheses. Now, based on the order of operations, I have to do that first and then multiply. Okay. Second one, very similar. I've got two things to do. I've got to triple something. I know that means times 3. Okay. But I have to triple the difference between these two numbers. Okay. Difference, I know in math, means subtract. Okay. So if I want to find triple the difference, that means I have to have the difference first. So finding the difference has to be my first step. Tripling it has to be my second step. So if I'm going to write this expression, first I'm going to have to find the difference, which means 44.75 minus 22.8. And then, I say I'm going to have to move my sign a little bit up here so we can see. Then I'm going to have to triple it. Okay. Times 3. Okay. But once again, that expression is not going to end up matching because with this expression, I would do the times 3 first. I have to make sure I include those parentheses around the subtraction. Once I put the parentheses around the subtraction, then I'm doing exactly what it's asking me to. First, I'm finding the difference because even though it's subtraction, it's in the parentheses, so that's my first step. Then I would multiply because that's outside the parentheses. Okay, number 5 says to multiply 4 times 7/8. So that's one thing I have to do. Then, okay, so this is my first step. This is my second step. Add 12. Okay, so let's start by just writing that out. 4 times 7/8. There's no tricky vocabulary here. Add 12 plus 12. Okay. Now, this one's a little different because this one I actually don't need to add parentheses at all into my expression. If I leave it this way, I'm following order of operations. Somebody comes along, sees my expression. What's the first thing they need to do? Multiply, because there's no parentheses. So first they're going to multiply. Then they're going to do the addition. They're going to do it exactly like I wanted them to. So I could just leave it this way and it would be perfectly fine. But I like better safe than sorry as an expression too. So I'm going to put my parentheses in anyway, because there's nothing wrong with putting in parentheses when you don't need to. So I just like to stay in the practice of every time I'm writing a multi-step expression, I put parentheses to show what my first step is, whether I need to or not. It's just giving somebody some extra directions and making sure that they know, hey, I want you to do this first. So I just like to put it in every time, better safe than sorry. Next one is very similar. Okay, I need to add 49 to the quotient of 125 and 5. I know that quotient means divide. But if I'm looking to add to the quotient, that means I've already found the quotient. I've already found the answer. So that means this step is coming first and then this one, which means my expression would say first 125 divided by 5. And then I'm going to add 49. So just like the one before, this is fine as is, because if somebody came along and followed order of operations, they would divide first and then they would add. But I'm going to put in my parentheses, even though I don't need them, just to be very, very clear. That's what I want you to do first. Okay, now I thought I'd put in a couple of examples of word problems because we know those can be the trickier kind, and see how this would work when it's not just a couple of directions, where it's actually a word problem to think about. So if you look at the very bottom of this page, the last one on page 749, number 11, asks you to write an expression to find the total area of the rectangles. So I know total altogether, all of them, and I know area is length times width. Here's my rectangles. Oh, I see I have 3 of them. So I need the total of all 3 of them together. To find the area of each one, I have my length, I have my width, 18 times 22. Okay. So that's the first thing I'm going to do, is I'm going to find the area by doing 18 times 22. Since that's my first step, I think I'll just go ahead and put that in parentheses. Okay, that's the first thing I'm going to do. Oh, this one is also 18 times 22, and this one is also 18 times 22. So it looks like I have two choices here. I could just add the 3 together. I could do another 18 times 22 and another 18 times 22. That's one way to do it with the repeated addition. Here's the area of one and the area of another and the area of another. Okay. But since it turns out when I look at it carefully that all 3 of them are the same, I know there's another way I could do this. I could do just 3 times the area like that. I could do, okay, first step, find the area, 18 times 22, and then multiply it 3 times because there's 3 of them that are exactly the same. So either one of those is an acceptable expression for this. Notice I'm not putting equal signs on any of these because they're asking me for an expression. If they ask me for an equation, I would have to put an equal sign and either the answer or a variable like n to represent the answer. But since they're saying expression, I can just put the calculations and leave it alone. Number 12 and number 13 on the top of the next page, 750, are very similar problems. So I thought we'd practice with a couple more word problems that are more real life situations. So I've taken some quick notes. You can read out the whole paragraph, but I've taken some quick notes of the information I thought I would need to solve it. And now we need to see if we can turn it into a numerical expression. $25. David is renting something for 5 hours. It costs him a $25 fee plus $15 per hour. And he's going to rent it for 5 hours. I want to find an expression for the total amount that he's going to pay. So I need to know a couple things. The $25, that is a one-time fee. It only happens once. But the $15 is per hour. $15 for each hour. We know that this is a fancy word for each, which is a fancy word for multiply. Okay, and I see that it is 5 hours that he's doing it. Okay, so this part is just going to be 25. Only happens once. You pay $25 to do it, and that's it. But then you pay an extra $15 for every hour that you use it. So I'm going to do 15 times 5 because it's $15 each for 5 hours. Now, I don't really need the parentheses if you're wondering, because if I didn't have the parentheses, if I just left it alone, and I was following my order of operations, as people always do in math, what do I do first? I multiply, and then I add. So either way is acceptable. Again, I like the parentheses. Lets people know I know how to use them and makes it extra clear to people solving. That's the first step to do. Okay, and the final one that we're going to do together is number 13. Okay. Here's a bunch of information I've got for number 13, an art situation where I have 14 students. Those 14 students are buying an easel for $129 and a bunch of canvases for $46. Sales tax is $10.50. They want to share the cost equally, so I want an expression for the amount that each paid. So I have a lot of information here. They bought an easel for $129 and canvases for $46. Sales tax, I always know, gets added on to everything I buy in all my vast shopping experience. This is clear. So I know that those are all 3 things I'm going to add together, and that's going to get me the total that they spent. So I think we're adding, because we're not talking about equal groups being put together, we're talking about 3 different numbers I'm putting together. Then I see that they shared. I know that's a clue word for dividing because they're sharing equally the cost. And of course, that would be the total cost I've already found. Gee, what are they dividing by? Oh, that's what I need. I need 14. They're dividing by 14 to share it equally because there's 14 of them. So my expression would be, first I want to find the total, 129 plus 46 plus 1050. That's the first thing I want to do. And here I really do need parentheses because I'm adding and dividing. So if I don't put parentheses, people would not add first. They would have to divide first. So first I put my parentheses to show, add those 3 numbers together first, and then I divide by 14 to get the answer for what each person would be contributing. Now notice, even though there's 3 numbers in that first step, it's fine because it's all adding. So I know I can add more than 2 numbers at once. I can make that all one step because I can just line up all 3 numbers and add them together. Then I can divide by 14. So I hope that was helpful. If you tried it on your own, you were able to check. And if you didn't try it on your own yet, hopefully you have a clearer idea of what you're expected to do. And you can go back and try the rest of 749 and 750 independently. And then, of course, do your practice buddy to get more practice with writing expressions for problems. And I will see you another day.